Hi everyone. Today we're going to talk about centroids. For those of you who don't remember or don't know, a centroid is the geometric center of a two-dimensional shape that can be balanced upon as far as the object goes. So as long as it's uniform thickness and gravitational pull around the object, you can balance an object, a 2D shape, on its centroid. So it's the center of mass of that 2D shape essentially. So a couple of things here to kind of start with. First things first, the symbol for the centroid being marked out is actually this little guy right, oh, hang on, I messed that up there. It's this guy right in here. And the equations we're going to be looking at today will be these guys right in here. Now they look kind of complex and crazy, but they're really not that bad at all. Below you'll see what the notations all mean. So on the far left, right over here, we have the centroid of the complex shape. The sigma here is going to be the summation of a bunch of numbers. And we have x, y, and z, which is the centroid of a simple shape. A is area, and then I would be the individual shape themselves, and we'll go through that as we go through this step-by-step process. So some basic knowledge here. Finding the centroid of a simple shape is pretty straightforward. We have some simple basic ideas here. In a rectangle, it's going to be 1/2 of the height, 1/2 of the base. So if you have an entire shape that's, however many inches by wide and tall, if you divide it by 2, you'll find that in the height from its base here up to halfway, this will give you a line in which the centroid will be landing on. And something from the base, how far across in the x, halfway across, gives you a crosshair now. That intersection point is the centroid of that shape. For a triangle, it's 1/3 of the base, 1/3 of the height. For a half circle, it's 4r over 3 pi. I lost my symbol there apparently. So these are different ways to kind of find the centroids of simple shapes. Now on the half circle over here, it looks a little bit weird, but if you think about it on this guy, this 4r over 3 pi only gives you in the height how far up the centroid is. On a half circle, it'll always be balanced left to right. So it'll always be in the middle of the entire shape. So those are our basic shapes. We're going to go into a complex shape now and understand a bit more about where things are all at here. So this first step here is just to get the basic ideas here. Again, the centroid here will mark the point of which you can balance the object on. So if you had these shapes in front of you, cut out of paper or something, you can put your finger on that spot and balance the object on that spot. Now, to solve for a centroid of, say, this example over here, we're going to break it down into some simpler shapes. So I took my shape over here on the far left, and I broke it down into 3 shapes, a triangle and then 2 rectangles. To start the whole thing, gave us some numbers, some dimensions for it, and I numbered each of the shapes 1, 2, and 3 in the red there, and I made a little chart for myself here on the far right, where you'll see my shape 1, 2, and 3 as marked over here. Now, you'll see I have x being solved for here. What we do is we solve for x first, and then for y, or you can do y first if you really want to, it doesn't really matter. But we're going to solve for one direction at a time. So this whole thing kind of begins here. One thing to note, I marked the origin of the shape down here. The origin is an extremely important part to this entire process, and you have to always stem measurements from the origin. So keep that in mind as we go through this. You can see here in blue I have measurements for it. It's 4 inches wide. This first box is 1.5 inches tall, 1 inch tall, 1 inch tall, and 2 inches wide across here. So I'm a step ahead here right now, but we're finding the centroid for shape 1 right now, just in the x direction. So if you remember from before, it's going to be 1/3 of the base to find the centroid of a triangle. So I have here 1/3 of the base is equal to 2 over 3, because remember that the base of this here is 2 inches as shown here. So I said 2 over 3, giving us a number of 0.6 repeating. So I kind of marked this out visually, at least, in a green dashed line shown here. That green dashed line there is going to show the centroid in the x direction. So somewhere on that line is the center of that shape. So mark that on my little chart there. The next one here, shape 2, ends up being 1 inch, because we have from the origin, measuring from this origin line, how far over half of it is. 2 inches over the entire thing, so 2 over 2 gives us an answer of 1. Okay, and then the last one here, we're going to solve for the base divided by 2 for our last rectangle, and we're going to find that x in this case is equal to 2 inches. So from the origin, it's over 2 inches. Now, we want to find the areas next, and the areas are pretty straightforward. If you don't know the area equations for a triangle, it's base times height over 2. For a rectangle, it's just base times height. So I simply ran those numbers through, and I plugged in my answers over here in the chart. Now we're going to go ahead and finish this little chart out here and apply it back to our equation. So over here in the far right column, it's just a times x. So I simply said 0.6 repeating times 1. Well, it's 0.6 inches cubed now, so I have inches and inches squared. Same down for shape 2 and shape 3. In the equation, it looks pretty complex here. When you break it down, though, all it's saying on the top part here is this. So we have ax1 plus ax2 plus ax3. Because it's the sum of these numbers. Okay? And then on the other part, I have the area, the sum of the areas, so a1 plus a2 plus a3. That's the sum of the areas. So, think about it here. All we're doing is taking these two columns, here in red and here in blue, and plugging them into these numbers over here. So you kind of see my equation break down here, wrote the equation out. Below that I plugged in the numbers here, so the top of the equation is going to be the red area, because a times x, so if you add up those numbers, that would be the summation of those numbers. And then the same thing for the bottom part, I have the summation of the areas. So I end up with a number of 1.62 repeating here. What does that mean, though? Well, what that tells us is that on our original shape, on the whole object, our centroid is 1.6 inches away from the origin. So right now it lies somewhere on this line. Not quite sure where in the y yet, but it's somewhere on that line. So now we have to go ahead and find the y. Now, the nice thing here is that our areas are the exact same. The shapes didn't change, so our areas are the exact same. Now, when we're going through all of this, we're going to find ourselves finding some different y values here. So, let's start off with this entire process here. So, how we're going to do this now is we're going to break the same way down as the x, but there's one small change here. So if you look here, we use the same equations, just in the height now instead. So we have 1/3 height for our triangle. Now, 1/3 of anything is going to be 0.3 repeating, right? Well, you notice that in the y over here, I have a number 2.8 inches, not 0.3. Well, the reason for that is over here, we measure it from the origin. So, from the origin to the center of this object is not just 0.3, it's 0.3 from here, but it's going to be 1.5 plus 1 plus the 0.3 to get us to the center of that object as a whole here. So we have a 2.8 number instead of the 0.3. Now the same thing goes for other objects here. This centroid of this shape in the height will be 0.5. However, take that plus the 1.5 from the bottom here, so from here to here, 1.5 plus our distance there, it's going to be a total of 2 for the y. And our last one's 0.75. So we have a bit of a change there. You always measure from the origin. That's the one key part here, is measure from the origin. Now, the same way from before, we're going to find a y, so I did the equation across and just kind of said, oh, a times y is this, a times y is this, a times y is this. And we're going to plug that same information back into our equation, but this time in the y direction. So we find out that our y is a 1.25 inches when we're all said and done after you run through the equation. And that means that on the object, the centroid is where those two lines meet. So 1.6 in the x direction from the origin, and 1.25 in the y from the origin. And that point there marks the centroid of this shape. Now, my drawing is not perfect by any means, but it gets you a good idea about where centroids lie in this object. So that's kind of how you go about solving for centroids of complex shapes. And I hope that this helped you in any ways. If you have any questions, post comments, please. Thanks. Bye.